Example 15, a jet of water 75 mm in diameter has a velocity of 36 meters per second. It strikes a single vein which has a deflection angle of 60 degrees and is moving with the same direction as the jet with a velocity of 12 meters per second. Find the components of forces exerted by the jet on the vein and the work done by the jet on the vein. So because the vein is moving, let's draw the figure. So this is the deflection angle. This is the value of u. Then because there is velocity of the vein 12 meters per second in the same direction as the jet, then this is the resultant velocity at point 2. So from the figure, Fx is q prime rho quantity v1x minus v2x. That's the formula. Where q prime is area times u and u is v1 minus v prime. So v1 or v1x 36 minus v prime 12 24 meters per second. So let's evaluate q prime rho because this is the same q mass flow rate to be used for Fy. So q prime rho is pi over pi area times u. Pi times 0.0375 square times 24, then density 1000 of water, so 106.03 kilogram per second. Then we can now, let's now compute V2x. From the figure, V2x is this horizontal component of V2, which consists of 12 meters per second plus, because this is u, and the angle here is 60 degrees, so plus u cosine of 60. So V2x is 12 plus 24u cosine of 60. 24u, then cosine 60. So it is also 24 meters per second. So substitute in this formula. Fx equals 106.03 quantity 36 minus 24. So Fx is equal to Rx also, the resultant going to the right. Resultant force exerted by the jet on the vein is 1272 newtons rightward. Then Fy equals q prime rho quantity v1y minus v2y. v1y is 0, then v2y is just the y component of u, so 24 sine of 60. Fy is 106.03 quantity 0 minus 24 sine of 60. So Fy is negative 2204 newtons, therefore Ry, which is equal to Fy, is 2204 newtons downward. Then finally, for the work done by the jet on the vein, it is Fx times v prime. So 1272 times 12 in joules or Newton meter, 15264 joules.